My name is Dr. Mike Murphy. I'm an assistant professor of computer science and information systems at Coastal Carolina University. In this lecture, I will discuss process management. I will discuss process context, context switches, and process scheduling. Each process running on a system has a certain amount of information associated with it. A minimal set of state information that allows a process to be stopped and later restarted is called process context. Process context includes the current contents of CPU registers, the current program counter value for the process, and the contents of RAM that the process is using. Switching between processes on a system is often called a context switch, although process switch is a more precise term. The operating system can perform a context switch from a process into a section of the kernel and then back to the same process without actually performing a process switch. Context switches require at least one mode switch to perform, since the CPU must enter supervisor mode to enter the kernel. Relatively speaking, context switches are a fairly expensive operation, and frequent context switching will reduce system performance. Whenever the operating system needs to switch from one process to another, it must first make a context switch into the kernel. The kernel then saves the state of the previously running process and restores the state of the process to which it is switching. A second context switch is then required to start the newly restored process. On Unix systems, processes are created via the fork system call. Following creation, the CPU scheduler determines when and where the process will be run. Once a CPU core is selected, the dispatcher starts the process.